Hello, everyone. This is Dr. Amir Abbas, and today I am here once again with another session in this series of online sessions. Let me remove this banner online so that we can just start the session. Uh, this is going to be a very short session, and the objective of this specific session is to give you an idea on how to conduct different statistical tests using R. And before we go into conducting these tests in R, what we are going to do is going to revise and revisit a few basic concepts, which will be uh, pretty much a repetition for most of you if you have taken some statistical courses, and it may be new for some of you if you have not taken statistical courses. So before going into R, I'm going to talk about different scenarios, and I'm going to talk about only two variables if you want to find out the relationship between two variables, and for the sake of simplicity, we're going to talk about some very common cases. So let's assume we have one variable and we have the second variable. And most common situation, it's always the case that either one of the variable is going to be a qualitative variable and the second variable is going to be a quantitative variable, right? Sorry, so one of the variable will either be a qualitative variable or a quantitative variable, and same will be applied for the other variable as well. It means that both of the variable we can either classify each one of them into qualitative variable or the quantitative variable, and same for the other variable. So we can formulate this 2 by 2 table where we have one variable and the second variable on the top and the side, and for each variable we will find out whether that specific variable is a quantitative variable or that specific variable is a qualitative variable. So that is the ground on the basis, or that is the framework on the basis of which I'm going to explain some basic concepts. So if both of the variable are qualitative, then to make it very simple, without going into the further details related to assumptions, we will be commonly we will be we will be conducting chi-square test. So specific example of this condition is if you want to find out relationship between gender and smoking status. The first variable is gender, and it has obviously two levels. If we consider gender as a binary gender, and the second variable is smoking status, which can also be dichotomized into yes and no. So in this scenario, we'll be conducting chi-square test. Now, if there are two variables and we want to find out the relationship between two variables, and if both of them are quantitative, then we'll be finding out Pearson correlation coefficient between both of them. Uh, Again, the example of this situation is the relationship between height and weight, and we'll find out height being the quantitative variable and weight being the quantitative variable. So we'll find out Pearson correlation coefficient between height and weight if you want to find out the relationship between height and weight. As I said, that there are other ways to find out the relationship, but I'm just oversimplifying it just for the sake of this specific discussion. Uh, Now, the third scenario is that if one of the variable is a quantitative variable and another variable is a qualitative variable, and the qualitative variable has another characteristic to it, which is that there are two levels uh, uh, for the qualitative variable, then we will conduct independent samples t-test. For example, if you want to ask this question whether BMI differ across genders, then to find out whether the BMI is different across male or female, BMI is a quantitative variable, and gender, if we assume as male and female, then that is a qualitative variable, BMI being a quantitative variable, and we'll conduct independent samples t-test in this case. Moving forward, just a minute, I lost track of my screen, I'm sorry. Okay, so and the fourth situation in this 2 by 2 table is that if one of the variable is a quantitative variable and the second variable is a qualitative variable, but the levels or the number of levels of the qualitative variable are more than two, which may be 3 or 4 or more than that, then we will use one-way ANOVA. And one specific example of this is, does height changes across ambiguous clauses, and height is a quantitative variable. Ambiguous clauses, traditionally we have 5 ambiguous clauses, so we will use one way ANOVA. So this is some basic background. Before I wanted to go to our code, I just wanted to talk about this uh, this background. And now what I'm going to do is to talk about uh, a few further details. And what specifically I want to do now is to uh, share my screen again and show you how can we compute independent sample t-test and chi-square test with the help of R code. Just a minute, just give me a few seconds. It will take me a few seconds to share my screen again. It's giving me some problems, so I apologize for that. And let me just give me a few seconds so that I can. I'm I'm going to unshare the uh, PowerPoint window and going to share the R code. Okay, this is not good. Okay, what I'm going to do is to share my whole screen. Okay, so and I hope that you are able to see my uh, okay, this is, let me actually try to share it again. I apologize for this inconvenience caused. I'm trying to share my screen again. Yeah, now this time it should work. Okay, I don't know where it was the problem, but now you should be able to see my screen where I have the R studio opened. Okay, and the objective of this session is to help you understand how to conduct independent sample t-test and R, and to conduct chi-square test with the help of R. Now, before starting to walk you through this small piece of code, I have to acknowledge that I've adopted this code from this link. I'm going to put that into the description of this video as well. Uh, First thing first, you have to load all the related needed libraries. For this demonstration, I need tidyverse and plotly. These are the two libraries which I need. So this piece of code, what it's doing, it is loading tidyverse and plotly. The next, what I'm doing is I'm going to use this birth weight data set, which is from this mass library. So what this piece of code is doing is use this mass library, but just take the birth weight data set from this mass library, save that as a table, convert that as a table, and save it into the data frame which is known as birth weight. So I'm going to, if I'm going to run this code, so it's going to load it, and the subsequent portion of the code is, and what it's doing some data manipulation. If you are interested in that, you can go through that in your own free time, but it's not the focus of this specific discussion. What I'm interested is now, as I alluded to you in the previous session, that if you want to see the structure of a loaded data set, we can use the str function, and with help of str function we can see that this data set has 189 values and 10 variables, and there are a few variables in which I'm interested. For example, I'm interested in birth weight, uh, which is a categorical variable, and birth weight, which is a continuous variable, so quantitative variable. These are the two variables which I'm interested in. And I'm also interested in smoking status. So what I'm interested in is, for this demonstration, is to check whether there is a relationship between smoking status and the birth weight or not, right? uh, so before going any further, I'm going to run some basic descriptives. And what I'm going to do is to take this birth weight data set, and from the birth weight data set, with this dollar sign, when you put the dollar sign in front of the data set, it's going to take out that variable. So I'm going to take out this mother spokes variable, and I'm when I put that in the brackets and run this code with the table function, it gives me the frequencies of how many individuals are having yes and how many individuals are having no as a response to this specific variable. And so this is just uh, the first variable in which I'm interested in. The second variable which I'm interested in is uh, birth weight in grams. And I do it in the same way. I take the birth weight, I use the dollar sign, and birth weight is the data set. I use the dollar sign, and with the help of this dollar sign, I'm going to extract the variable known as birth weight in grams. I'm going to use the summary function. What the summary function is going to do is going to compute all the parameters for me for a quantitative variable, which is the minimum, first quantile, median, mean, third quantile, and the maximum. So these are some things which I'm interested in, and summary function will do this all for me on its own. Now, what is happening? If you remember in the scenarios which I shown to you on the PowerPoint slides, is that we have the situation where we have one of the variable which is a quantitative variable, and the second variable is a qualitative variable, and the qualitative variable has two levels, which is yes and no, right? So we are going to use independent sample t-test in this situation. For uh, uh, before running an independent sample t-test, what I am going to do is to plot this and see how birth weight in grams varies across genders. So what I'm going to do, I'm going to use the ggplot function, and I'm going to take the birth weight data set and put mother smoking status on x-axis and birth weight in grams on y-axis. And I'm going to draw a box plot, and I'm going to put a nice X label and a Y label and a graph chart, and I'm going to save the whole of this code or the whole of this graph into this variable P, right? It's not going to do anything because I've not printed it. So with the help of ggplotly function, which I've explained in the previous session, is I'm going to uh, uh, print out or run this, and it's going to take a while, and it's going to make an interactive box plot for me where mother smoking status is on x-axis and birth weight is on y-axis. And you can see that there seems to be some difference in it between those who smoke and those who do not smoke in terms of the birth weight. But if we want to see whether this difference is statistically significant or not, we have to run independent sample t-test. Here I have to emphasize that I'm just going towards independent sample t-test without checking any assumptions. Ideally, in the real world, I will check some assumptions, whether the assumptions of the independent sample t-test are met or not. But because that is not the teaching independent sample t-test is not the objective. Rather, the objective of this session is just to teach to you how independent sample t-test can be run with the help of R. Therefore, I'm just jumping into that. And even before going into that, what I'm going to do is compute the mean birth weight and standard deviation of birth weight at the levels of those who smoke and those who do not smoke. So the way it can be done, what I'm going to do is I'm going to take this birth weight data set, I'm going to pipe it, which means that I'm going to forward it to this group by function. And what group by does is groups by uh, the mother smoking status. And in then I'm whatever comes out from that, I'm going to pipe it, and I'm going to ask to give me a summarize with the help of this summarize function. Within the summarize function, I can specify what do I need as an output of the summarize function, and as an output I need for each levels how many observations are there. So for that you can use n and this two bracket signs. Then with the help of the mean function, you can find out the mean birth weight in grams at the level of mothers who smoke and who do not smoke, and the standard deviation of mothers who smoke and who do not smoke. So if I run this thing, the whole of this thing, what I get is a table which is showing me the number of observations, the mean birth weight, and the standard deviation of the birth weight at the level of those who smoke and those who do not smoke. And there are a few comments, a number of, let me see. Okay, so the question over here is, how do we test assumptions in R? Yeah, yes, we can test assumptions in R. For example, obviously, like a simple, straightforward answer to this question is that you always use Google. I use Google. You when once you just like get familiar to our interface, you just like Google, okay, how do you check normality in R, how whatever the other assumptions are, because that's not our topic, so we are not going to go into those details. That okay, but you simply Google and you will get a code, and then you use that. So that is a very simple answer to that. Since running the assumptions or the details related to independent sample t-test is not our topic, so unfortunately I'm not covering it. Maybe in the later sessions where I will be covering, I will focusing uh, in my parallel series in which I'm recording the videos rather than producing them as a live stream. I may cover this thing in detail, where I'll produce separate videos on t-test, separate video on chi-square test, and separate videos on individual tests. There maybe I answered this question, but right now I think that's not the scope of this specific talk. Okay, so moving forward from this table, now running p-test is very simple in R. Okay, what you need to do is, okay, so this, what I'm going to do, like, R has a function which is known as t.test. This is the function which you are going to use, and this function has a few arguments. And the first argument is your quantitative variable, and the second argument after this tilde is your qualitative variable. So the quantitative variable is birth weight in grams, and the qualitative variable is mother smokes. And then after, so you are going to use it in this way, like the quantitative variable tilde the qualitative variable, and then you are going to say data equal to whatever the name of the data set is, right? I can run it directly, but I can here what I've done, I have saved it to another variable. The output has been saved to this variable, which is known as t underscore test. So I have to run it again to print it out, and it's going to give you this whole of the output. You can read it from here as well, there's no problem in it, but I would encourage you to understand the structure of this variable, which is known as t underscore test, because that's going to be very important for you. For example, if you go a bit advanced in or a bit forward, what you will want to do is to, for example, I would want to like isolate only this t-test statistic, or I will be interested in isolating only this p-value. And what I mean by isolating is that, okay, I can just, one way of doing that is that, I can just copy it and just paste it here. Okay, that's one way to do it, but that's not what you want to do. What you would be interested in doing is that with the help of your code, you should be able to just print out the p-value or the test statistics or the confidence interval or the level of confidence or the other parameters which are there in the whole of this output. Now there are number of reasons to do that. I'm again not going to explain all the reasons why that is important. That will also be explained in one of my subsequent videos, but that is something which you would be interested in doing. So first of all, what I can do is, with the help of this names function, I can understand what is contained in this, because you can understand this t-test variable as a bag. This bag is, the structure of this bag is a list, and it has a number of components in it which you can separate. So one way to see, okay, I want something to tell me, okay, open the bag and see what is contained inside it. So I'm going to use the names function and put this variable t underscore test as the argument. It's going to tell me, okay, it has statistic, which is the test statistic, it's a parameter p-value, and a number of other things, which means that I can extract these things from this t underscore test variable. What I'm going to do is that I'm also interested in knowing what is the type of this variable, because that becomes important at times, to know the type of the variable, as you can do some types of manipulation or some data structures and not other manipulations on other data structures. So if I write type of this t underscore test, and it comes out to be list. Okay, so okay, as I said that, and I'm going to go again into the if you see, like, this t underscore test variable that has the whole of the this output, and I am now interested, first of all, let's go step by step. If I am interested in extracting only t test statistic from this, right, how am I going to do that? And the reason I'm going to need that is, at times you are going to, this document which I'm working in, that is known as R markdown. So what you are going to do at times is if you're writing a paper, what you would want to do is to refer or use that specific variable in your writing, so that it automatically updates rather than you manually updating it. Let me explain that in a bit. But so what I'm going to do over here is that I this t underscore test is a list, and I'm going to use this dollar sign, and with the help of this dollar sign, so let me demonstrate it over here in parallel. So if I type t underscore test and I enter dollar sign, then it's going to open a drop down menu for me, which if you can compare with the output of the names, these are exactly the same, right? So you can approach or you can access these things with the help of this dollar sign. So if I print this specific line, what you can see, it's printing only the t test statistic only for me, right? So that's exactly what I've done over here, is that I've extracted the test statistic. I've saved it to another variable of t statistic, and then I've printed that. So if I run the whole of this code, the same is going to be the printout of that. And now what I'm interested in, why I do that, right? Let me explain that in a bit, because this is going to be quite interesting and a very important strength for R. Is that if I'm converting, or if I'm converting this into a report or a paper, what I'm going to do is that we found that the t t statistic was, so one way is to, like, okay, I will do this thing, I will just copy and I will paste it over here, right? Okay, this is also something which will work, right? But this is not recommended in R, because let's assume something changes, your variable changes, your sample size changes, your sampling strategy changes, right? What you are going to do, you are going to do uh, what you are going to do is you have to manually change it again. So a better way to do this, I extracted this variable. What I'm going to do, I'm going to copy this variable, and I'm going to use this. There is, if you see on your keyboard, there is some below the escape key. There is something which is a tilde, and if you press shift and press tilde, after pressing shift and tilde, sorry, not uh, like below the escape key, there is a key which has tilde on it, and if you press that key without pressing shift and then press R, okay, then and then write this variable inside this code, like, so when you knit this thing, it is going to show this number right now. Now if you could not understand this part, that's completely okay. That was kind of an aside from this specific discussion. But at this point, what you need to know, that you will at times need to extract these variables from the complex output of the t-test statistic, because you can let your text to be automatically updated. Okay, let me go there, because I think there was some other question. So what is type of for? So let me go back over there. So whatever you have, whatever variable you have, right? If you're not sure what is that, one way to see is you have this function which is known as type of, and you find out the type of that variable, and it will give you numeric, it will give you character, it will give you list, it will give you double. And we kind of walked through these data structures in a hurry in our first session. And but if you know, okay, something is a list, something is a character, you can do some things with that, not the other things with that. So type of will tell you, okay, what is the type of this variable. That's what the function type of is doing. Going forward, now the next thing which I'm interested in is extracting the p-value from this variable, which is test statistic. What I'm exactly doing, I'm going to do that. The exact same thing is to type that variable and to press the dollar sign and then like extract the p-value. And if you see, the p-value will be there. That is the exact thing what I've done, but I've saved it to p-value and just like printed it out again. In the same way, I can print out the confidence interval, extract it, and now you can see that confidence interval in itself is a in itself has many things, right? And if you want to extract the lower limit of the confidence interval, then you can uh, use these two brackets and parentheses, and then like the first lower confidence interval will be printed. And if you use uh, so if you put one in these brackets, the lower confidence interval will be printed like this, and if you put two into them, then the upper confidence interval will be printed. And you can also, what you can do is save them into two other values. I will say ci lower, and I can call it ci underscore upper, right? I can print it like that, and when I print this variable, it's going to print out the lower confidence interval. And in the same way, if I print the other variable, which is the ci underscore upper, it's going to print out the upper level of the confidence interval. That is how you can extract the individual components from your from the output of uh, yeah, in the t-test. So I hope this was a bit clear. If it's not clear, you can ask questions, or if you're watching it live, you can ask question live, and if you are watching its recording, you can type the question in the comments, and I can answer them later in subsequent videos as well. Okay, so with that, I'm going to move towards the second important demonstration related to this talk. As I told you, that this is going to be a short talk, but it is quite important, because this skills t-test or chi-square test, that are some of the most important statistical tests which we perform in our statistical analysis. So I kind of chose them. I chose not to talk about a lot of stuff, but a few things, because these are kind of very new concepts, and I didn't want to bombard you with a lot of statistical concepts. So the next thing what I'm going to do is to find out, if you remember, let me go into the structure of the data set over here. And if you see, now I'm going to apply a chi-square test. So one of the variable which I'm going to use is whether mother smokes or not, right? And the second variable which I going to use is this categorical variable, or the qualitative variable, which has two levels, uh, right? And that is whether the birth weight is below or above 2500. So I'm going to check the relationship or association between these two variables using the chi-square test. And how am I going to do that? Let's move to the point where we were. And first of all, what I'm going to do is to do a simple cross tabulation, as you will do in SPSS. And what you do is you extract the first variable, which is the categorical variable for the birth weight. And the way you extract that variable is take the name of the data frame, use the $sign and name of the variable. That way you extract the first variable. You extract the second variable in the same way, and you put them, both of them, inside this function which is known as table, and it's going to print out a simple cross tabulation. I have to remind you that this cross tabulation is oversimplified. It doesn't have any kind of proportion. You can manipulate it to print out proportions as well, but that is not the intent at this point in time. It's just showing the numbers. Over here, what I'm going to do, I'm going to save this table, which is exactly the same code. I'm going to save this into another variable, which is a birth weight bw underscore table, which is, so I'm going to save this into this thing, right? Okay. And what I can do over here, I can take this table and use R has this function which is known as chi-square test. So this is the name of the function, which is chi-sq.test. Okay, and I'm going to run it on the output of the first line, or that table which I printed out over here. I'm going to run this code, and let's see what happens. So it is printed out chi-square test output for me. And again, like the previous situation, it's again a combination of a number of things, and I'm not interested in this. I want to extract the chi-square test value, and I am interested in p-value and maybe other details of that. So what this next line of code is doing, it's doing the exact same thing, but it's kind of running it on this directly. So what I've done over here is just save into another variable and run the chi-square test of it. So this, you can ignore this line because it's doing the exact same thing. uh, and here so rather, what I'm doing over here is I'm going to save this thing, the output, into chi-square test, chi_test variable. And in the same way I checked for the names where for the t-test, I'm going to check the names of this with the help of the names function. I'm going to check what is contained inside the chi-square test, and that will tell me that what is inside it. Okay, so as you can see, that has test statistic, that has parameter, p-value, method, and a number of other details. And in the same way, if I want to extract that test statistic, I can do that with the help of putting a dollar sign in front of that variable, which I just saved over here. And you can see that test statistics for chi-square test is this 4.23 4.235 something, right? You can extract the p-value, and you can also extract other parameters from this output. So this was a very short demonstration, and it was intentionally short to keep us focused and to introduce this concept of how to run a chi-square test and t-test, independent samples t-test on R. And in the subsequent videos, we are going to extend on this concept. We're going to talk about a number of other tests which are ANOVA and a few of other tests, and we are going to move towards the linear regression and logistic regression. Those of you who have stayed online with me online, I'm thankful to you. Those of you who have stayed online through this live stream, I'm thankful to all of you. And those of you who would be watching this recording, you can give me your feedback or your questions in the comments. I will put the reference to this code in the description of this video. Take care for the time being.